All right, so let's finish this real quick from 18 through 21. So let's see. So first thing, 18 and 19. Let me change this question. This is how you guys have them right now. But let me change this real quick, right? You guys learned the unit circle yesterday, so we did that already. Let me change the question. So if you need to copy the question, pause the video, copy the question. Like I said, I'm going to change these questions. That way, just we match our homework a little bit better. This is how questions 18 and 19 are going to be. Like I'm just changing them so just so we matched our homework a little bit better. I want us to review how to write the fractions and the 6 fractions like sine, cosine, tangent, cosecant, secant, and cotangent. So I want us to review those. I want to give you guys triangles and I have the 3 sides and I'm going to mark an angle. I forgot to mark the angle here, number 19. So I'm going to mark an angle. So based on that angle, the 3 sides have a name, right? As in opposite, adjacent, hypotenuse. Let me take a look at number 18. I know the big side is the hypotenuse. So this is the hypotenuse based on the red angle. So based on the angle that I marked, this side is the opposite and this side is the adjacent, right? Opposite means far away, adjacent means close to. And I'm going to ask you for your homework, I'm going to ask you for different values. I could ask you, give me the sine of theta. Or the sine of the angle, right? Remember sine, we learned that it was opposite over hypotenuse. So it's just going to be 4/5. I could ask you for the cosine of theta. And I know cosine, we know it as adjacent over hypotenuse. Remember, I gave you the acronym CA. Cosine is adjacent over hypotenuse. So it's 3/5. And then tangent. Tangent, remember I gave you the acronym TOA. Tangent is opposite over adjacent. So 4/3. And it's okay to have improper fractions. Improper means the big number on top. It's okay to have that. It's fine. But at the same time, I'm not going to limit myself to just those 3 ratios. Remember, ratio is a fancy word for fraction. I can ask you for the cosecant of theta. I could ask you for the secant of theta. And I can ask you for the cotangent of theta. Now, cosecant is the reciprocal of sine. So sine is 4/5, cosecant is 5/4. Secant is the reciprocal of cosine. Since cosine is 3/5, secant is 5/3. And the same thing for cotangent. Cotangent is the reciprocal of tangent. Since tangent is 4/3, cotangent is 3/4. Notice I answer all 6 ratios. I could ask you for any of those ratios. I could ask you for any 2, any 3, any 4, or I could even ask you for all 6. It's okay if the numbers are all whole numbers, like we see here in number 18, or it's okay if you deal with decimals, right? Let me label my sides. The hypotenuse is the big side. Based on the red angle, 2 is my opposite and 5 is my adjacent. And again, I could ask you for sine of theta. I could ask you for cosine. I could ask you for tangent. I could ask you for cosecant, secant, and cotangent. Right? Those are the 6 ratios that we have. Sine, remember the acronym. I even gave you an acronym. Let me write it down here. So okay, so I guess this thing froze. So we have the acronym SOHCAHTOA. Sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite of adjacent. I label my 3 sides based on the red angle. And we know that sine is opposite over hypotenuse. So I'm just going to go 2/5.39. Just because the number is a decimal doesn't mean it has to be treated in a whole number. It's just opposite over hypotenuse. It's okay to have decimals. Now cosine, I know cosine is adjacent over hypotenuse, so 5 over 5.39, and tangent is going to be 2 over 5. My cosecant is going to be the reciprocal sine, so 5.39 over 2. Secant is the reciprocal of cosine, so 5.39 over 5. And cotangent is the reciprocal of tangent, so 5 over 2. So far, those should be simple, right? I'm giving you guys all three sides of the triangle. I mark one angle so you guys can see which one is the opposite, which one's the adjacent and hypotenuse. And I can ask you for any of the ratios. Same thing, I want you to also use for the last two questions here, 20 and 21, I want you to use your unit circle. Remember, we filled it out yesterday, so you should have it filled out. And remember, as a reminder, let me just go here. That's a reminder, my coordinates are X and Y when I look at X and Y values. But I can also call them cosine of theta and sine of theta. For you to not get confused, which one comes first, cosine or sine? Which one is X? Which one is Y? Remember, X and Y were alphabetical order, so X was first. The same thing here, right? I'm in alphabetical order. And then we also said the sine, right? We saw this yesterday, sine divided by cosine, it's equal to tangent. Remember we saw that. Okay, so let's take a look. Here, I need you to find secant of theta. So I want you to find secant, but I'm gonna say, so we're finding secant, but the sine of theta is gonna be radical 2 over 2. And theta is in quadrant 1. Okay, so look at in quadrant 1, look at the point where the y value is radical 2 over 2. There's a point where the values are radical 2 over 2 and then radical 2 over 2. I'm looking at quadrant 1, the point where the y value, because I'm looking at sine, so the y value is radical 2 over 2. That is 45 degrees or pi over 4. I don't know if you're looking at this in degrees or radians. Okay, so I'm looking at that. So now I need to know, now I know I'm looking at 45 degrees. I need to find the secant. Okay, so remember I said secant is the reciprocal of cosine? I know cosine, right? I know cosine is radical 2 over 2. So secant, let me change this to red. Secant is going to be 2 over radical 2. Because I do the reciprocal of cosine. The only thing is that it has to be or in a way that I don't have radicals at the bottom, right? It says rationalize, no radicals at the bottom. There's a radical 2 at the bottom. So let me multiply top and bottom by radical 2. Because the thing is that at the bottom, I'm just going to have a 2. That's what I want. I don't want radicals at the bottom, right? Square root of 2 times square root of 2 is just 2. When you multiply a radical by itself, you just get the number on the inside. On the top, I have 2 radical 2. Pay attention to this fraction, 2 over 2. Isn't that 1? Right? So my answer in this case is just radical 2. Okay, cool. Let's take a look at another question. We need to find tangent of theta. So my answer here, my question here, I'm finding tangent. And I know tangent is sine divided by cosine. My cosine is a negative radical 3 over 2. And my theta is in quadrant 3. So I want you to take a look at the unit circle And I want you to find the coordinates of the point where the x value is negative radical 3 over 2. Again, I'm looking at the third quadrant. Use your unit circle. Isn't that 210 degrees? Right? The x value is negative radical 3 over 2, and the y value is a negative 1/2. Remember, the cosine is the x value, sine is the y value. Now I need to find tangent. And I know tangent is sine of theta divided by cosine of theta. So in my case, it's a negative 1/2 divided by a negative radical 3 over 2. Let me just take a look at the negatives. There's two negatives, so my answer will be positive. Oh, and it's divide, right? It's not times. I wrote times. Now I know in the division of fractions, I'm going to write this as 1/2 times 2 over radical 3. Notice I switch it to times and I flip the second fraction. These two simplify, they cancel out. So I have 1 over radical 3. So my tangent is 1 over radical 3. I have to rationalize. No radicals at the bottom. So let me multiply top and bottom by radical 3, because at the bottom, I'm just going to have 3. And on the top, I just have 1 radical 3. Now, those 3's cannot cancel out. Right? In this fraction, those 3's cannot cancel out because one of them is inside a square root. The other one is not. And then also notice the one outside of the radical, I chose not to write it. But if you do write it, you're okay. I chose not to write it. So that's okay.